for year 11 methods, we're going to look at exercise 16D, question 1. Now, 16D is actually a very, very important exercise, only because it's like an introduction to what calculus is all about. So if I have a curve like this, and let's just say I want to find the gradient at x equals 1. So this is hypothetical. Now, the gradient at x equals 1 happens to be what the gradient of the tangent is at x equals 1. Okay, so if I draw a, tangent, if I draw a tangent here, then that's the actual gradient of that point, okay, at x equals 1. Now, the problem is we haven't learned yet how to find the gradient of something at any particular point, okay, because we know how to find the gradient of secants. That's like the average rate of change, okay. So if I were to find the gradient at x equals 5 and x equals 1, that's easy. You just go the point at x equals 1, which is here, and the point at x equals 5, which is here. You're just drawing you're just finding the gradient of the secant joining x equals 1 and x equals 5. Now, hypothetically, what happens if we get closer? Well, we get a better idea of the gradient at x equals 1 because it's actually closer to the 1. So what happens if I draw a line like this is that it's approaching a better estimation of the gradient. And it's not very good, but get the idea, right? So what happens if I go 3? We get an even better estimation, okay? 2, we even get a better estimation, okay? But you get the idea, right? As we get closer and closer and closer to 1 itself, if we're trying to find the average rate of change between 1 and a number very close to 1, you get a very, very good approximation of what the grade at 1 equals to. And this is what the question is trying to do. Okay, we've got a graph and we're trying to find the gradient at x equals 1.2. Now they've chosen a point very close to 1.2, so 1.3 is relatively close to 1.2. So they're just trying to find the average rate of change between these two to approximate. And let me emphasize the word approximate. We're only approximating the average instantaneous rate of change at x equals 1.2 because we haven't learned the exact method yet. Okay, so we're just approximating. Now, what would even be a better point to choose apart from 1.3? Well, 1.21 would be better because that's even closer to 1.2. Okay, even better would be 1.20001. Okay, even better would be 1.200001. Okay, so these are extremely close to the point, except 1. But we'll just make life simpler. We'll just choose 1.3. So, how do I get the average rate of change between points to estimate the instantaneous rate of change? You just sub into the original equation. So x equals 1.2 when x equals 1.3. You're just trying to find the corresponding values. So here's the calculator. This. Okay, so you're just going to go. When I sub in x equals 1.2, this is the equation. So I'm subbing into here. I get 1.2 squared cubed plus 1.2 squared. And then you've got 1.3 cubed plus 1.3 squared. I'm just doing both one. So 3.168. Okay, so that's let's go back here. 3.168, and what was the other value? 3.887. 3.887. So my average rate of change is just basically the which approximates the instant rate of change. Rate of change at x equals 1.2. So it approximates the instantaneous rate of change at 1.2 would be y2 plus y1 over x2 plus x1. So I'm just going to do the calculator. We should get a value. Let's see what we get. So use the fractional 3.87 minus 3.168 divided by 1.3 minus 1.2. 7.19. So 7.19 would be my approximation of the instantaneous rate of change at x equals 1.2. Okay, so it's not going to be exactly the rate change at x equals 1.2, but it's an estimate. Just think about that. So hopefully that helps.